Hello friends. Today we'll see the curve tracing when the equation given is in parametric form. So whenever the equation is given in parametric form, okay, it is always in this format. So x is equal to f of t, y is equal to g of t. Here t is the parameter. Okay, sometimes instead of t, theta can be used as a parameter. Okay, but always any curve represented in parametric form can be written in this way. Okay, so there are two equations. Fine. Now, how we will trace the curve? So we will go with the same points, that is symmetry, tangent, passing through origin, etc. So all that we will check. Only thing is that checking with parametric form has a different kind of rules. Okay, so let us here list out what kind of rules that we have. These rules you can take as a steps, okay, in solving this problem. So first thing is that you decide the symmetry. Okay, again the symmetry is about x-axis, about y-axis, or about both axes simultaneously. Okay, so what are the rules? So the rules is for symmetry, so let us note these rules. If x equal to f of minus t, so if I say f of minus t is equal to f of t and g of minus t equal to minus g of t. Okay, this means that f is a even function and g is a odd function. Okay, so I write that here, f is even and g is odd function. Okay, what then? Then the curve is symmetric about x-axis. Then curve is symmetric about x-axis. Okay, so this is first rule. B, the opposite of this, that is if f of minus t is minus of ft and g of minus t is equal to g of t. Okay, what it means? That means f is odd and g is even. That is f is odd and g is even. Okay, then the curve is symmetric about y. Fine. The curve is symmetric about y-axis. There is another rule when the curve is symmetric about y-axis. So let me write that rule over here. So I am continuing the P. Okay, so either this part or I say if f of pi minus t is minus f of t and g of pi minus t is g of t, then curve is symmetric about y-axis. Okay, so either you can use this rule for y-axis symmetry or you can use this rule. Okay, now there is third part, C. Both are odd functions of t, then the curve is symmetric about both axes. Okay, so if I say f of t is minus t is minus f of t and g of minus t is minus g of t. Okay, then so both are odd functions of t, right? Then curve is symmetric about both axes. Okay, curve is symmetric about both axes. Fine. So this is about symmetry. Uh, then how we will decide that the curve is passing through origin? So you find out a value of t for which x is equal to 0 and y is equal to 0. If such a value exists, then you say that the curve is passing through origin. So this is next rule, passing through origin. Okay, so find a single value of t for which x equal to y equal to 0. Okay, uh, if such value exists, then curve passes through origin. If such t exists, then the curve passes through origin, and else it is not. Otherwise, not. Okay. So this way you can decide how the curve passing through is. Now, here in parametric form, the important thing is to find out the nature of the tangent at different values of t. Okay. So how you will get the nature of tangent? That means the slope of the tangent. So the slope of the tangent can be obtained by, now see that your equation of the curve is in this format. So next rule, nature of tangent. Nature of tangent. Okay, how will decide this? So you find out dy by dx. Now how you get dy by dx? Here there are two functions of t, right? And we have learned in 12th how to take the derivative of the parametric form equation. So we will use that. So we'll write this as dy by dt divided by dx by dt, right? And we can find out dy by dx for different values of t. That gives me the slope of the tangent to the curve at different points. Okay, and with this slope, we can decide uh, the nature of the curve, right? Here, you please note one thing, that you prepare a table. So this is a very important point when you are tracing the curves in parametric form. Prepare a table of a t, x, y, dy by dx. So what we are doing actually, for different values of t, okay, ranging over the given range, we are preparing the what the x value is, y value is, and the dy by dx calculated in this way. And from this table, then we can easily determine the nature of the curve, and we can draw that curve, right? Okay, so we have covered almost every point in this parametric form. Please note all these rules. We'll see the example in the next video. Thank you.